Greetings, my dear listeners. Today we embark on a journey that cannot be made aboard a spaceship. It is a journey of thought, imagination, and science, leading us toward the most mysterious frontiers of reality, to a place where the familiar laws of physics collapse, where time ceases to flow as we understand it, and where matter itself becomes a riddle. I am speaking, of course, about the event horizon and the secret that lies beyond it. Imagine a star, millions of times more massive than our sun. It lives its life, burning brightly, shedding light, perhaps nurturing planets in its orbit. And then, at last, its fuel is exhausted. What happens then? Collapse begins. Matter folds inward under its own weight with such force that no power in the universe can stop it. And thus is born what we call a black hole. This is not merely an object in space. It is a place where our very notions of space and time unravel. The event horizon is the boundary beyond which even light cannot return. It is as if the universe itself has drawn an invisible line, warning us, beyond this point, there is no road back. And yet beyond that boundary lies the thing we most crave to understand, the singularity. For decades, physicists and philosophers alike have wrestled with the question, what is a singularity? Is it a point of infinite density? A tear in the very fabric of space and time? Or perhaps it is a reflection of our own limitation, our inability to express in equations something that defies logic. When Einstein wrote down the equations of general relativity, he could not have imagined that his mathematics would lead us into such paradoxical territory. Pause for a moment. We are used to believing that everything can be measured, that all things can be explained, described, understood. But what if there exists a place where mathematics itself surrenders? Are we doomed never to glimpse the very heart of a black hole? Or could it be that behind the event horizon lies the key to the architecture of reality itself? History gives us reason to hope. Galileo lifted a crude telescope to the sky and saw the moons of Jupiter, demolishing centuries of dogma. Newton wrote laws that explained the fall of an apple and the orbits of planets alike. Einstein dared to imagine space and time as inseparable, and in so doing, he upended the very framework of science. Why should black holes be any different? But make no mistake, black holes were not easily accepted. In the 18th century, John Michell speculated that a star might be so massive that its gravity would trap even light. In the 20th century, relativity confirmed such a possibility. And then, slowly, reluctantly, the astronomical evidence began to accumulate. These bizarre creatures really do exist. Yet what truly draws us to them? Is it their strangeness, their danger? Or is it that they remind us of our own boundaries? The event horizon is not only a line in the cosmos, it is a metaphor for the thresholds in our own lives, moments beyond which nothing is the same again. Consider Stephen Hawking. Confined to a wheelchair, his body uncooperative, his voice reduced to a synthetic whisper. And yet his mind ventured farther than anyone's. It was Hawking who suggested that black holes are not entirely black, that they emit faint radiation now known as Hawking radiation, that they are not eternal but mortal. The universe's ultimate prisons, it turns out, can evaporate into nothing. What a staggering idea, that even darkness can give off light. And so we come to a philosophical pause. If even black holes are mortal, then what is eternal in this universe? We search for permanence in the stars, in numbers, in spiritual truths, but perhaps eternity itself is only a reflection of our longing for stability in a world where everything flows, everything changes. Humanity has always sought answers. We built religions, philosophies, sciences to bring ourselves closer to the truth. But every answer births new questions, and black holes may be the most vivid expression of this endless quest. We look to the night sky and know, out there, hidden in the darkness, are objects that challenge not only our instruments, but our imagination. Perhaps one day future generations, or perhaps intelligent machines of our own making, will find a way to peer beyond the event horizon. Perhaps they will unify quantum mechanics and general relativity, and the singularity will cease to be a mystery. But until then, it remains the dark heart of the cosmos and of our curiosity. So, my dear listeners, this is the beginning of our voyage. We have sketched the outline of the event horizon, heard the stories of great scientists, paused for philosophy, and dared to ask questions about endings and beginnings. And yet, this is only the first step. Ahead lie more riddles, more questions, more wonders. We continue our journey, my dear listeners. Now that we have looked upon the event horizon as a boundary, a symbol, a challenge, let us go deeper into the very idea of a boundary itself. For every time humanity has confronted a limit, it has had two choices: to accept it, or to step boldly forward and redraw the map of what is possible. Think back to antiquity. For the Greeks, the world ended where the sea stretched into endless blue. Beyond the horizon lies the abyss, they thought. And yet, sailors set out nonetheless. Some returned, some perished. But with every voyage, the boundary moved farther away. Is this not exactly what we face with the cosmic horizon of a black hole? The event horizon is not simply a line in space. It is a frontier where light itself falters, and at the same time it is a mirror of our own hunger to explore. Why are we so drawn to the impossible? Why do we invent theories, build telescopes, devise paradoxes? Precisely where nature seems to forbid us? Perhaps because somewhere deep within, we know that to be human is to transcend. In the 20th century, many scientists resisted the idea of black holes. They seemed like absurdities of mathematics, not realities of nature. Even Einstein himself doubted they could exist in the physical universe. And yet, observations pressed relentlessly on, and slowly the evidence mounted. They are real. Then, in 2019, humanity saw the shadow of a black hole in galaxy M87. The Event Horizon Telescope, a monumental collaboration of hundreds of astronomers around the globe, stitched together data from radio telescopes to reveal the unseeable, a glowing ring of light around a dark center. It was not just a scientific result, it was a cultural moment, a philosophical statement. We had glimpsed the unglimpsable. Ask yourself, what did you feel looking at that image? A shiver? A sense of smallness? Or perhaps pride? That humanity, in spite of wars, crises, divisions, could unite to peer into the very heart of darkness? That photograph is like a map maker drawing the outline of a new world. But this time it was not an island or a continent. It was the border of being itself. And does that not remind us that no boundary is final? But let us be honest. What are we truly searching for in the depths of space? Do we seek knowledge for its own sake? Or are we really seeking answers to personal questions? Who are we? Why are we here? Where are we going? Perhaps the black hole fascinates us not only as a physical mystery, but also as a metaphor for the unknowns of our own lives. Think of it this way. Each of us has our own event horizon, a line beyond which lies uncertainty, the first step into a new career, the decision to move to another city, the loss of someone we love. We know only what lies before the line. What lies beyond is hidden, and yet we step forward, we risk, we cross. And only then do we discover that there is a new world waiting for us. Here we might recall Kip Thorne, a scientist who not only studied black holes, but also helped millions of people imagine them through art. It was his calculations that shaped the stunning black hole Gargantua in Christopher Nolan's Interstellar. For the first time, a broad audience could see an image rooted in scientific truth. Is this not proof that the boundary of science meets the boundary of imagination? And so let us ask, could imagination itself be our tool to cross horizons? Physicists write equations, engineers build telescopes, but it is imagination that takes the very first step. Without imagination, Galileo would not have lifted his telescope. Copernicus would not have dared to dethrone the Earth. and Hawking would not have dared to say that black holes shine. Perhaps horizons exist precisely so that imagination can overcome them. But here lies another thought. What if some horizons cannot be crossed? What if the event horizon truly is the ultimate line, and no daring, no dream can take us past it? Are we prepared to accept such a limit? Or will we forever seek detours, new theories, new models, new visions? It is on boundaries that paradoxes arise. Take the paradox of information. Does information vanish forever inside a black hole? Or is it somehow preserved at the horizon? For decades, the greatest minds debated fiercely. Hawking argued one way, his rivals another. Each move was like a chess match with reality itself. Is this not exhilarating? When we argue about black holes, we are not arguing about distant objects. We are arguing about the very meaning of exist, persist, disappear. These are questions of physics, but they are also the oldest questions of philosophy. So, my dear listeners, the event horizon is more than a cosmic boundary. It is a symbol of overcoming, of daring, of risk. It is a metaphor for our own lives, and it is a reminder that the unknown is not to be feared, but engaged. And so we take our second step. We have seen the event horizon as both scientific and symbolic, as both a challenge and a mirror. Ahead lies a greater question. What truly lies inside the black hole? That is where our journey will become even more thrilling. My dear listeners, we now dare to move closer, beyond the symbol of the horizon itself, to ask the question that has haunted physicists, philosophers, and dreamers alike. What lies at the very heart of a black hole? What is the singularity? To speak of singularities is to step into forbidden territory. It is the place where our equations break, where infinities arise, where science itself stares into a mirror and admits, I do not know. But is ignorance not the truest beginning of knowledge? Let us begin with the definition. A singularity, in the context of a black hole, is the point where matter collapses into infinite density. Imagine compressing the earth into the size of a marble, then into the size of a grain of sand, and then smaller still, until all of it is squeezed into a single point. At that point, the curvature of space-time becomes infinite. And yet we must pause. Do infinities exist in nature, or only in our mathematics? Einstein's equations predict singularities, but Einstein himself doubted them. He believed that nature must somehow avoid such extremes. Roger Penrose, in the 1960s, proved mathematically that singularities are inevitable outcomes of gravitational collapse. Stephen Hawking extended these ideas to the universe itself, suggesting that the Big Bang was also a kind of singularity. Thus, the beginning of all things and the end of stars share the same mystery. Think about that. The singularity of the Big Bang gave rise to galaxies, planets, life, and the singularity of a black hole seems to devour them. Creation and destruction, joined at the hip. What a poetic symmetry. Pause with me here. If the universe begins with a singularity and ends in singularities, what does that mean about the cycle of being? Is reality itself born and reborn in these fiery, invisible crucibles? Or are singularities the ultimate do-not-enter sign in the cosmic landscape? Scientists struggle to describe them because general relativity and quantum mechanics, our two greatest pillars of physics, give contradictory answers. Relativity says space-time curves into infinity. Quantum mechanics says infinities cannot be physical, and some deeper law must intervene. It is here, at the singularity, that physics cries out for unification. Some dream of string theory, tiny vibrating strings that make up all particles, perhaps smoothing out the harsh infinities. Others dream of loop quantum gravity, a vision of space-time made not of a smooth fabric, but of tiny, discrete loops like threads in a woven cloth. Both seek to tame the singularity, neither has yet triumphed. But is not the very search a testimony to our resilience? Let us recall an image. Imagine a traveler falling into a black hole. To the outside observer, the traveler freezes at the horizon, never crossing. But to the traveler herself, she crosses and continues, pulled toward the center. What happens next? According to relativity, she is crushed at the singularity. But according to our longing hearts, perhaps something else awaits. A bridge to another world, another time, another universe. The idea of wormholes emerged from this longing. Einstein and Rosen once suggested that black holes could connect distant regions of space-time. Later, the concept of Einstein-Rosen bridges, or wormholes, captured the imagination of scientists and storytellers alike. Could the singularity be not a tomb but a doorway? And yet here philosophy reminds us, perhaps we invent doorways because we fear endings. Perhaps the singularity is not a passage, but a mirror held up to our mortality. We, too, are finite. We, too, face horizons from which there is no return. And so the black hole becomes an allegory of our human condition. But listen, to admit our limits is not despair. It is courage. When we say, we do not know what lies at the singularity, we are not confessing defeat, but inviting imagination, theory, art, and faith to step in. The singularity is an emptiness we fill with meaning. History is full of such moments. Once lightning was a mystery, attributed to gods. Once disease was explained by spirits. Each time mystery yielded to understanding. Why should singularities be any different? Perhaps what seems like an end today will be tomorrow's discovery. So, my dear listeners, what lies at the center of a black hole? We cannot yet say. Perhaps infinite density. Perhaps a doorway. Perhaps a new universe. Perhaps only the limits of our own mathematics. But whatever the answer, the very act of asking binds us to the cosmos. For to ask what is a singularity is to ask what is reality. And that is why we continue forward. For in the next step of our journey, we will see how black holes do not merely warp matter, but warp time itself, and in that warping lies another secret. The strange elasticity of reality, where seconds stretch into eternities. We now arrive, my dear listeners, at one of the most fascinating aspects of black holes. Their power to bend and distort not just space, but time itself. It is here, near the event horizon, that the clock begins to falter, and our very notion of before and after grows uncertain. Let us begin with a simple idea. We are accustomed to time flowing evenly. Seconds tick by, minutes accumulate into hours, and we live our lives as if this flow were absolute, yet relativity teaches us otherwise. Time is elastic, it slows down in stronger gravity. It bends, it stretches, it responds to the mass of the cosmos. Now picture an astronaut approaching a black hole. For the astronaut, time seems normal, her heartbeat, her breath, her watch, all steady. But for a distant observer watching her fall, her motion slows. Each second grows longer, stretched into eternity. At the very brink of the event horizon, she seems to freeze, forever suspended, never quite crossing. Is this not reminiscent of myth, where heroes are trapped between worlds? Popular culture has given us vivid images of this. Recall Interstellar, where a planet near a black hole experiences such extreme gravity that hours on its surface equal decades outside. Though dramatized, this idea comes directly from relativity. It is no fiction. Gravity does stretch time. And what a humbling realization that now depends on where you stand in the cosmos. Pause with me. If time flows differently in different places, does a universal now even exist, or is every present unique, bound to the observer who experiences it? And if so, then perhaps reality itself is not a single thread, but a vast tapestry, each strand a separate rhythm of time. Science resisted these notions at first. The early 20th century clung to the comfort of absolutes. But Einstein persisted, and experiments proved him right. Today, even our GPS satellites account for relativity. Without correcting for time dilation, navigation would fail. Ideas once thought metaphysical are now woven into daily life. Yet at the edge of a black hole, relativity shows its most dramatic face. not only time but space itself stretches. Objects falling inward appear to elongate, stretched thin along their path. This grim effect, dubbed spaghettification, is the ultimate testament to how alien reality becomes under extreme gravity. Terrifying, yes, but also a reminder that space-time is alive, not static. Let us remember Karl Schwarzschild, who first solved Einstein's equations for such a case. Amid the chaos of World War I, from the trenches, he sent his calculations to Einstein. In them lay the first glimpse of the event horizon. Imagine a man surrounded by destruction, writing equations that revealed a cosmic abyss. Does this not show how human curiosity persists, even in the darkest hours? Here we must pause again. If even time itself can bend, what then remains truly absolute? Perhaps only our questions. Perhaps the one constant in the universe is the human drive to seek, to wonder, to cross new horizons. And so black holes teach us. Time and space are not backdrops to reality. They are the actors. They warp, they flex, they play their roles upon the stage of existence. And if reality itself is elastic, then what is real? Is reality a fixed thing, or is it the dance of processes, ever shifting? Modern physics seeks to merge this vision with quantum mechanics. For while relativity reigns on cosmic scales, the quantum world insists on probabilities, on uncertainty, on particles that are waves and waves that are particles. At the event horizon, these worlds collide. There, perhaps, lies the doorway to a unified theory, and black holes hold the key. So, my dear listeners, we have seen how time slows and stretches, how space elongates and bends. We have revisited the stories of the scientists who uncovered these truths, and we have asked ourselves, what is reality? If even time is not absolute. Ahead lies the next wonder, light itself and how black holes bend, trap, and even release it. For in the interplay of light and darkness, we find not only science but poetry. Now, my dear listeners, let us turn to light, the most faithful companion of our exploration of the universe. Everything we know of distant stars and galaxies, every image of cosmic beauty, every discovery of the skies, comes to us carried by light. It is the messenger, the witness, the language of the cosmos. And yet, near black holes, even light begins to behave in ways that defy our ordinary sense of nature. What happens when a beam of light strays too close to a black hole? Gravity bends its path, curving it like a river drawn into a whirlpool. There is a special region called the photon sphere, where light can orbit the black hole in circles, trapped but not swallowed. A precarious dance. One slight disturbance, and the photon either escapes outward or is lost forever within. From this interplay emerges one of the most haunting images in all of science, the shadow of a black hole. In 2019, humanity saw that shadow for the first time. The Event Horizon Telescope presented us with a glowing ring of fire around darkness itself. Some saw a scientific triumph. Others saw a philosophical icon. For the first time, we saw something that by definition cannot be seen. Is this not a miracle of both knowledge and imagination? But let us reflect. What does it mean to see a black hole? We do not see the singularity itself. We do not glimpse what lies inside. We see only the light distorted, bent, captured, delayed. We see the last struggle of photons fighting against gravity. In a sense, the image of a black hole is not of the hole at all, but of light's defeat and its resilience. And yet from this defeat, knowledge is born. The bending of light, the shape of the ring, the size of the shadow, these are clues. They tell us about mass, spin, dynamics. Light becomes our interpreter, our bridge to what we cannot touch. Even in losing, light guides us. Here we recall Stephen Hawking's profound insight, that black holes are not entirely black. On the quantum scale, pairs of virtual particles arise near the event horizon. One falls in, the other escapes as radiation. This faint glow, now called Hawking radiation, suggests that black holes slowly evaporate, shedding their mass, eventually fading away. Darkness, it turns out, can shine. Pause with me here. What symbolism lies in this? We have long equated light with truth, with life, with hope, and darkness with ignorance, with fear, with death. But black holes invert this symbolism. From darkness itself arises light. From the devourer comes a quiet gift back to the cosmos. Does this not remind us that endings themselves may contain beginnings? The history of visualization is also worth recalling. Jean-Pierre Luminet, in 1979, produced the first computer-generated image of a black hole. With limited technology, painstaking calculation, and creative persistence, he showed the world how such an object might look. Decades later, his vision was vindicated. One man's imagination anticipated the work of global telescopes. Is this not the essence of science and of art? But light also raises deeper questions. If what we see around a black hole is only distorted reflection, how can we ever claim to know the truth of what lies beyond? Do we live always among shadows, like in Plato's cave, glimpsing only the play of light upon a wall? And if so, is truth itself something forever hidden? Or is the search for it the truest reality? Think, too, of the future. Gravitational lensing already allows us to see galaxies, otherwise invisible, their light bent by cosmic giants. Perhaps one day we will use black holes themselves as lenses, unlocking sights that no telescope could otherwise reach. Light, once trapped, could become the tool that shows us farther than ever before. So, my dear listeners, today we have seen light's strange fate at the edge of darkness. We have walked through the photon sphere, looked upon the shadow, remembered Hawking's radiation, and paused to ask what it means to see. And we have discovered that even darkness can illuminate. Ahead, we will turn to matter itself, to the cosmic drama of how black holes consume, transform, and even create. Our journey continues, my dear listeners. Today, let us turn our gaze not to light, but to matter itself. For black holes are not only destroyers. Paradoxically, they are also among the brightest engines of energy in the universe. Their very act of consuming matter gives rise to spectacular displays of creation. Picture a star straying too close to a black hole. Gravity tears it apart, shredding it into streams of gas. That gas spirals inward, forming what scientists call an accretion disk. In this disk, atoms collide at unimaginable speeds. Temperatures soar to millions of degrees, and the matter shines, not in visible light, but in powerful X-rays detectable by our telescopes. Thus, the black hole reveals itself not by what escapes, but by what it devours. Here lies a paradox. That which should vanish into darkness blazes forth before it disappears. Matter, in its final struggle, produces light more brilliant than entire galaxies. There is tragedy in this, yes, but also grandeur, as though the universe itself writes dramas of sacrifice. And black holes do more than consume. They expel. From their poles burst colossal jets of plasma, streams of particles propelled at near light speed, stretching across thousands of light years. How can this be if nothing escapes? The secret lies at the edges, in magnetic fields and rotational energy. It is not matter from within the horizon, but energy harnessed from the swirling storm outside. And so, the black hole becomes not only a grave but a fountain. Think about that. An object named for darkness becomes one of the universe's brightest beacons. Is this not a lesson for us, that even in consuming, life may create? In the 1960s, astronomers discovered quasars, quasi-stellar objects so luminous that they outshone entire galaxies. For years, their nature was uncertain. Eventually, the truth emerged. At their centers lurked supermassive black holes, millions or billions of times the mass of our sun, feeding on matter and blazing across the cosmos. The monsters of destruction were also architects of cosmic beauty. Pause here. If black holes can create such power, might one day humanity harness them? Science fiction has long imagined civilizations that draw energy from black holes, using them as engines for interstellar voyages. Theoretical models, such as the Penrose process, suggest ways to tap the rotational energy of a black hole, Could our distant descendants one day light their worlds with the power of these cosmic furnaces? Even if that dream remains distant, the insight remains. Black holes are not only destroyers, they are participants in cosmic evolution. They shape galaxies, regulate star formation, and distribute energy across vast distances. Without them, the universe itself would be different. Let us ask a more personal question. When we hear the word consumption, we often think of endings. But in black holes, consumption gives birth to brilliance. Could it be that in our own lives, moments of loss and letting go are also moments that create light? Perhaps endings, too, can shine. History gives us examples of perseverance. In 2020, Andrea Ghez and Reinhard Genzel received the Nobel Prize for proving the existence of a supermassive black hole at the center of our own galaxy. By tracking the dance of stars near the heart of the Milky Way, they showed the invisible giant shaping their motion. It was a triumph of patience, observation, and faith in data. Once again, black holes revealed themselves, not only in destruction but in orchestration. So, my dear listeners, today we have seen black holes, not as tombs but as engines. We have witnessed their power to shred matter, to blaze with energy, to sculpt galaxies. We have asked whether humanity might someday draw from their strength. And we have remembered that even in endings, light may be born. Ahead, our journey will turn to the grandest scale. What role do black holes play in the destiny of the universe itself? Do they herald its death or its renewal? That is the question that awaits us next. My dear listeners, let us now step back and ask a grander question. If black holes can consume matter, bend light, distort time, and even shape the birth and death of stars, what role do they play in the destiny of the universe itself? Could it be that within their darkness lies the script of cosmic fate? We know that black holes are born from the collapse of massive stars, but in the hearts of galaxies dwell titans far greater, supermassive black holes, millions or billions of times more massive than the sun. These giants are not mere passengers in their galaxies. They are conductors. Research shows a striking correlation between the mass of a galaxy's central black hole and the number of stars within that galaxy, as though the growth of galaxies and the growth of their dark hearts are woven together. Think of what this implies. Black holes do not merely devour. They regulate. Their jets and radiation heat surrounding gas, slowing the formation of stars. In other cases, compression of gas near them may trigger bursts of starbirth. In this way, they become architects of cosmic structure. The destroyers are also creators. Pause here. How paradoxical that an engine of endings becomes the very organizer of beginnings. Does this not mirror our own lives, where moments of crisis often give rise to transformation? But what of the far future? If Hawking was right, black holes are not eternal. They slowly radiate away their energy, evaporating over inconceivably long spans of time. Long after stars have burned out, long after galaxies have faded, black holes may remain as the last monuments of matter. The universe could pass into an era dominated by black holes, dark giants whispering their radiation into the void. And then, one by one, even they will fade. What remains then? Silence. Emptiness. The void. It sounds bleak, perhaps, but let us ask, is the end truly a tragedy, or is it part of the cycle? Even if the universe dies, our search to understand it imbues meaning. We live, we question, we dream, and that is our eternity. Other theories exist. Some imagine the universe will not end in heat death, but will collapse and be reborn. Perhaps singularities are seeds, and black holes are wombs of new creation. Might our universe itself have been born from the collapse of a black hole in another cosmos? If so, then endings are never truly endings, but transitions. Is this not the myth of the phoenix, retold in cosmic terms? Here we might recall Roger Penrose, who proposed conformal cyclic cosmology. He suggested that our universe is but one eon in an endless sequence of universes. each leaving imprints upon the next. If so, black holes are not tombs, but messengers across eternity. Is this not a vision both humbling and inspiring? Pause again. When we think about the future of the universe, we are really thinking about ourselves. We too face finitude. We too seek meaning beyond the horizon of our own lives. Perhaps that is why cosmic fate fascinates us. It is a mirror of human fate. History tells us that people have always yearned to see beyond the end. Religion spoke of judgment, rebirth, eternity. Ancient myths spoke of floods, fires, renewals. Science speaks now of entropy, cycles, multiverses. And in all of these we hear the same voice. We cannot bear the thought of nothingness. We reach even into darkness for meaning. And black holes, oddly enough, teach us hope. Even in their death throes, they shine with Hawking radiation. Even in consuming, they sculpt galaxies. Even in endings, they harbor new beginnings. Perhaps this is their lesson to us, to leave light behind even as we fade. So, my dear listeners, today we have glimpsed black holes as guardians of cosmic destiny. We have seen them as destroyers, but also as sustainers, as creators, as seeds of universes yet to come. And we have reflected on our own mortality, our own search for meaning in the face of endings. Ahead lies an even bolder idea, that singularities themselves may not destroy, but create entirely new worlds, that each black hole may be a doorway, and that beyond every ending, another universe begins. My dear listeners, let us now take an even bolder step into imagination. We have seen black holes as destroyers, as engines, as guardians of cosmic destiny. But what if they are something more? What if each singularity is not an end, but a beginning? What if black holes are the wombs of new universes? This idea is known as the hypothesis of baby universes. The thought is this: when matter collapses into a singularity, it may not vanish into nothing. Instead, it might pinch off, birthing a new bubble of space-time, a fresh cosmos with its own laws, its own stars, its own history. To us, from the outside, the story ends in collapse. But from the inside, the story begins with a new creation. Pause for a moment and imagine. What if our own universe began this way? The Big Bang, too, was a singularity of sorts. We do not yet know what caused it. Could it have been the death of a black hole in another universe, seeding ours into existence? If so, then we are children of collapse, descendants of a cosmic lineage stretching back through endless generations of universes. Is this not breathtaking? In such a vision, reality is infinite not just in space, but in time. Endings and beginnings are woven into an eternal chain. The death of one world gives rise to the birth of another. The Phoenix myth, written into the fabric of physics. Scientists such as Lee Smolin have even imagined a kind of cosmic natural selection. In this view, universes that produce more black holes are more likely to spawn offspring. Thus, the very laws of our universe, gravity, particle masses, physical constants, may have evolved to maximize black hole formation. In other words, we exist in a universe finely tuned to give birth to others. And the fact that black holes exist is evidence that this process works. Pause again. What does this mean for us? If every black hole is a doorway to a new universe, then there are not one but countless universes. An infinite multiverse, each world as real as ours. And what then is reality? Do we live in the only true world, or just in one of infinite possibilities? And if there are infinite possibilities, does that not mean that imagination itself is a kind of travel? History tells us that wild ideas often lead to truth. Once the notion that Earth orbited the sun was radical. Once quantum mechanics was absurd. Perhaps today the idea of universes within black holes is another radical step awaiting confirmation. Whether true or not, it expands our vision. It stretches our horizon, and in that stretching lies its value. But let us not ignore the philosophy. Perhaps we create these visions because we fear the finality of death. Perhaps black holes are mirrors of our own longing, to see every ending as a beginning, to believe that nothing is truly lost. And perhaps that longing itself is the most human thing of all. Recall also the scientists who dared to dream. Einstein and Rosen with their bridges, Smolin with his evolutionary cosmology. Each took mathematics and imagination hand in hand and ventured into forbidden territory. Whether their visions prove right or wrong, their courage inspires. It reminds us that science is not only about proof, but about daring to ask impossible questions. So, my dear listeners, today we have looked at black holes as creators. We have imagined them birthing new universes, passing information forward like seeds of eternity. We have seen how such ideas echo ancient myths, and how they stretch both science and philosophy. And we have asked ourselves what it means to live in such a reality where nothing ever truly ends. Ahead we will turn to another frontier, for at the event horizon, relativity and quantum mechanics clash, and it is there, in the tension between the very large and the very small, that we may find the key to the long-sought theory of everything. My dear listeners, we now stand at the sharpest frontier of physics. We have seen how relativity describes the grand scale of space and time, and how quantum mechanics rules the microscopic realm of particles. Both theories have triumphed in their domains, but at the event horizon of a black hole they collide. Here lies perhaps the greatest unsolved puzzle of science, the conflict between the very large and the very small. General relativity tells us that space-time is curved by mass and energy. It predicts horizons, singularities, the bending of light, and the warping of time. It has been tested and confirmed in countless ways, and yet it is silent about the quantum world. It cannot describe particles, uncertainty, entanglement. Quantum mechanics, on the other hand, is the language of the microscopic. It describes atoms, electrons, photons. It has given us lasers, computers, medicine. It, too, has been tested and confirmed, but it falters when confronted with gravity. It cannot explain the smooth curves of relativity, only probabilities and fields. And so, when matter collapses into a black hole, when density approaches infinity, the two great theories clash. Relativity predicts a singularity. Quantum mechanics demands that infinities be resolved. Which is right, or is neither complete? This conflict gives rise to paradoxes. One of the most famous is the information paradox. If a black hole evaporates through Hawking radiation, what happens to the information about what fell inside? Quantum mechanics insists that information cannot be destroyed. Relativity seems to suggest that it is lost forever. Here is a contradiction at the heart of physics, and physicists have debated fiercely for decades, with no final resolution. Pause for a moment. What does it mean that our greatest theories contradict one another? Does it mean reality itself is contradictory? Or simply that our language of mathematics is incomplete? Perhaps, as in the past, a new theory awaits us, a new Einstein to unify the pieces. Various paths have been proposed. String theory imagines the universe woven from tiny vibrating strings, whose harmonies give rise to particles and forces. Loop, quantum gravity, imagines space-time itself as quantized, made of tiny loops, a fabric of discrete units. Other ideas abound: holographic principles, emergent space-time, even the radical suggestion that the universe is information itself. Each is a step toward reconciliation. None has yet triumphed. But here lies the beauty of science. The very contradictions are fertile ground. It is in paradox that progress begins. When Galileo saw the moons of Jupiter, he shattered the geocentric view. When Newton's laws clashed with Mercury's orbit, relativity was born. So too, perhaps, will the paradoxes of black holes give birth to a new synthesis. Pause again. Think not only of equations, but of meaning. If relativity and quantum mechanics are both true in part, then reality is more subtle than either alone. Perhaps the universe is not a machine, nor a cloud of probabilities, but something richer, more profound, beyond our current imagination. History reminds us of humility. Einstein himself never accepted quantum uncertainty. Hawking changed his mind on information. Geniuses stumble, argue, err, and yet through this struggle, knowledge grows. It is not perfection but persistence that defines science. So, my dear listeners, we stand at the crossroads of physics. The black hole is not only a cosmic object, but a crucible in which our deepest theories are tested. It asks of us, can we unify the very large and the very small? Can we find a language that speaks both of galaxies and of quarks? Perhaps one day a young physicist yet unborn will write the equation that unites them. Or perhaps the answer will not be an equation at all, but a new way of seeing. Until then, the black hole remains our teacher, challenging us with paradox, drawing us toward unity. And ahead, we will look not only at theories, but at culture itself. For black holes are not only scientific mysteries, they are symbols inspiring art, literature, and the human imagination. My dear listeners, let us pause from equations and paradoxes and turn our attention to culture. For black holes are not only objects of physics, they are also symbols, metaphors, and muses. They live in our stories, our films, our music, our very imagination. And perhaps through these reflections we come to understand them, and ourselves, in new ways. From ancient times, humanity has told tales of abysses, of endless pits and cosmic darkness. In Norse mythology, there was Ginnungagap, the yawning void. In Greek mythology, there was chaos, from which the world emerged. Do these not remind us of black holes, darkness that births creation? Writers of the modern age, too, have been drawn to these images. Arthur C. Clarke, Isaac Asimov, Stanislaw Lem, Stephen King. Each in their own way used the black hole as a symbol. For Clarke, it was a doorway to other forms of existence. For Lem, it was the unknowable, the frontier beyond which reason falters. Science fiction became the stage upon which humanity rehearsed its dialogue with the infinite. And then came cinema. Christopher Nolan's Interstellar gave us perhaps the most vivid cultural image of a black hole. With the help of physicist Kip Thorne, the film portrayed Gargantua, a visualization so precise it could have been a scientific paper. But the film gave us more than mathematics. It gave us hope, sacrifice, love, the reminder that even in darkness, human beings search for light. And is that not why we were all moved? Music, too, has found inspiration here. From symphonies that portray the struggle of light and shadow, to rock songs where the black hole becomes a metaphor for passion or despair, the symbol resonates. It is universal. We all know what it feels like to be drawn into something vast, powerful, consuming. Why does the black hole so captivate us? Perhaps because it mirrors our own inner lives. Each of us has a black hole within. A mystery, a grief, a silence. And yet, just as in the cosmos, even in darkness there may be hidden light. The metaphor is not only cosmic but deeply personal. Pause for reflection. Might art itself be an attempt to cross the event horizon? Scientists build telescopes to see the unseen. Artists create images, stories, melodies to express the unexpressible. Both are acts of defiance against the unknown. Both say, we will not be stopped by the horizon. History shows us how art anticipates science. Jules Verne wrote of submarines and rockets before they were built. Cubist painters fractured space on canvas before Einstein described its curvature. Might our cultural visions of black holes too guide our scientific understanding? And philosophy adds another layer. The black hole has become a symbol in psychology. We speak of the black hole of depression, of emotions being consumed. It is language that helps us describe the indescribable. And perhaps it reveals that cosmos and psyche are not so distant, that our inner worlds mirror the vastness above. The story of the black hole's discovery is itself cultural myth. Scientists doubted, argued, persisted, and when in 2019 we finally saw the shadow of a black hole, the world cheered as though we had landed on the moon again. It was not only a triumph of science, but of humanity, a reminder that curiosity and courage unite us. So, my dear listeners, today we have seen black holes not only as physics, but as culture. They live in myths and legends, in novels and films, in music and art, in our fears and our hopes. They are part of our soul as much as our universe. and that makes them all the more mysterious, all the more beautiful. Ahead, let us return to the question of the future. How might black holes shape the destiny of humanity itself? Can knowledge of them change our path? Can the very idea of the singularity inspire us to step into a new stage of civilization? My dear listeners, we now turn our eyes from culture to the horizon of the future. We must ask, can knowledge of black holes change the destiny of humanity? Could the very idea of the singularity become a key to our civilization's next great step? Let us begin with the practical. We live in an age where energy is the lifeblood of progress. Science fiction writers have long dreamed of civilizations that draw power from stars or even from black holes themselves. And this is not mere fantasy. Theoretical models exist, such as the Penrose process, in which the rotational energy of a black hole could be extracted through magnetic fields. Imagine such a source of power, a generator dwarfing all we know, enough to fuel journeys between the stars. Here lies a paradox both thrilling and humbling. The same objects that once symbolized endings could become engines of beginnings. They could be the cosmic Prometheus, granting us fire on a scale beyond imagination. Even if this dream remains far away, the thought itself changes us. To think of black holes as engines teaches us to look beyond the obvious. If even darkness can give rise to light, then perhaps in our own lives we can find solutions where none seem to exist. History shows that each new vision of the cosmos transforms society. Copernicus displaced Earth from the center. Newton's laws fueled the Industrial Revolution. Einstein's relativity reshaped technology, from GPS to nuclear energy. Might black holes ignite the next revolution? But there is another lesson no less vital. Black holes teach us humility. They remind us of limits. In an age where we believe technology can solve all, black holes stand as reminders. There are mysteries not easily conquered. Perhaps it is this humility that can save us, teaching us to tread lightly upon our planet, to value life, to cherish each moment. Pause for reflection. What does it mean to live in a universe where time itself can end, where light can vanish, where space can fold upon itself? Might this awareness awaken us to our own boundaries, and to the courage it takes to cross them? Already, black holes inspire progress. Physicists push equations, engineers build telescopes, writers and artists spin stories. Together they shape a vision of the future. A future where humanity is not confined to a single planet, but ventures boldly into the stars. Is this not the essence of who we are? Consider the symbol. Once, the emblem of humanity was the wheel, the book, the engine. Now it may be the telescope gazing into darkness. For it is there in daring to look at the unseeable that we discover who we are, seekers, explorers, dreamers. So let me ask, what matters more? The discoveries themselves, or the transformation they bring within us? Perhaps black holes will not only change our science, perhaps they will change our spirit, teaching us to live with mystery, to embrace the unknown, to welcome the horizon as invitation. Remember the image of the black hole's shadow in 2019. For a moment, humanity looked together at the same picture. Borders, languages, beliefs faded. We were one species staring into the abyss, and marveling that we had glimpsed it at all. Is that not a triumph greater than the data itself? So, my dear listeners, today we have looked forward. We have imagined black holes as future engines of power, as teachers of humility, as symbols of unity, and we have asked, what might they awaken within us? Ahead lies an even bolder question. What would it mean if humanity one day truly crossed the event horizon? Not in metaphor, not in imagination, but in reality. My dear listeners, today we take a step even bolder than before. We have asked what black holes mean for science, for culture, for the future. Now let us imagine what it would mean to truly cross the event horizon. Not in metaphor, not in art, but in reality. What awaits the traveler who dares the point of no return? Relativity tells us this: once across, there is no going back. To the outside observer, you never fully enter. You appear to freeze. fading into redder and redder light. But to you, the traveler, time flows normally. You fall inexorably toward the singularity. And here our knowledge ends. What happens next is the great unsolved mystery. Is it annihilation? Transformation? A doorway? Science fiction has long imagined this journey. Some stories send the traveler into parallel universes. Others confront them with alien intelligences or future versions of themselves. These visions, though speculative, reveal our longing to believe that beyond the horizon lies not only death, but discovery. Pause with me. Why do we long to cross such a boundary? Why are we drawn to the impossible? Perhaps because it mirrors our nature. We have always sought what lay beyond the ocean, beyond the mountain, beyond the sky, and now beyond the very fabric of reality. There is a philosophy hidden here. Each of us has horizons in life, moments after which nothing is the same. The choice to begin a new path, the loss of someone dear, the leap into the unknown. These are our personal event horizons. We too cross points of no return, and we too emerge transformed. History is filled with such leaps. Columbus setting sail into an ocean he did not understand. Magellan circling the globe without knowing if it could be done. The astronauts of Apollo stepping onto the moon. Each risked everything, each crossed a horizon, and humanity was forever changed. Some physicists even speculate that falling into a black hole might generate a new universe on the other side, that the traveler's end could be another world's beginning. What poetry lies in this idea that even in falling we give rise to creation, that our destruction might be someone else's dawn. Yet honesty demands humility. The reality, as far as we know, is harsh. Tidal forces near the singularity would tear matter apart, stretching atoms into threads. No vessel, no body could endure. The black hole is not a doorway for us, not yet. But the vision itself matters, for it stretches our imagination, and imagination is the seed of discovery. Pause again. What are we truly seeking when we dream of crossing the horizon? Are we seeking immortality, ultimate knowledge, or simply the thrill of facing the impossible? Perhaps it is all of these. Perhaps it is the echo of our deepest longing, to know that existence does not end but transforms. Think of science itself. Once heavier than air flight was impossible. Once splitting the atom was unthinkable. Once traveling to the moon was a fairy tale. What seems impossible today may tomorrow be achievement. Might horizons themselves be temporary illusions, waiting for courage and time to dissolve them? And philosophy whispers further, if one day we peer inside a black hole, will we not have to redefine reality itself? For now, reality means what we can measure, see, and verify. But if we step into a realm where these rules fail, what new meaning will we give the word exist? Consider also the inner journey. Crossing horizons is not only cosmic but personal. Grief, love, transformation, each reshapes us. Each is an event horizon we pass through, emerging someone new. Perhaps this is why black holes speak so deeply to us. They are metaphors of the soul as much as of the sky. So, my dear listeners, today we have dared to imagine the impossible. We have pictured the traveler who falls beyond the point of no return. We have asked what science says, what fiction dreams, what philosophy suggests. And we have discovered that even if we never make such a journey, the vision itself changes us. It teaches us courage. It invites us to leap. It whispers, the unknown is not the end, but the beginning. And so we come to the final step of our voyage. Next we will gather all that we have learned, all that we have wondered, and ask, what does it all mean for us as human beings? What vision, what inspiration? Can we carry with us into the future of our own horizon? My dear listeners, we have arrived at the final step of our long journey. We have traveled together from the birth of black holes to their shadows, from the bending of time to the clash of theories, from myths and music to visions of the future. And now it is time to draw our voyage to a close, not with dry conclusions, but with inspiration to carry forward. What have we seen? that black holes are not only cosmic objects, but symbols. They remind us that limits exist, but also that limits can be crossed. They teach us that endings may hide beginnings, and that even in darkness light can be found. Think of the symmetry. The universe began with a singularity, the Big Bang, and stars end in singularities, black holes. Creation and destruction mirror one another. What greater poetry could there be? Pause for reflection. If the cosmos itself is written in this language of cycles, then perhaps our lives are too. Each loss may carry within it a seed of new creation. Each ending may open the way for a beginning. We need not fear the horizon. It is the place where transformation begins. History gives us examples. Galileo daring to raise his telescope. Einstein daring to bend time. Hawking daring to think light shines even from darkness. These were human beings, fragile as any of us, and yet their courage allowed them to face the unknown. So too can we. The cosmos is not only for scientists, it belongs to all of us who wonder. Pause again. What does it mean to be human? Not merely to live or to survive. To be human is to seek, to reach for the horizon, knowing we may never return, but to go anyway. For it is in the reaching that we discover ourselves. We are small in scale, tiny beings on a fragile planet, circling a modest star, and yet we have peered into black holes, measured the echo of the Big Bang, and dreamed of universes beyond our own. Our greatness lies not in size, but in daring. Perhaps one day our descendants will indeed approach an event horizon, equipped with technologies we cannot yet imagine. Perhaps they will cross and glimpse what lies beyond. But even if that day never comes, the dream itself is enough, for the dream teaches us hope. It teaches us resilience. It teaches us to keep going. So, my dear listeners, let this be our closing thought. Each of us lives in our own cosmos. Each of us has our own stars, our own black holes, and each day we choose to turn back in fear or to step forward in courage. And I believe this: we are born to step forward. We are born to seek the infinite. Let black holes remind us that darkness is not the end, but a call, that even the deepest abyss may hide light, that the unknown is not a threat, but an invitation, and that our greatness is not in what we possess, but in what we dare to imagine. And so our journey ends and begins anew, for the horizon is always before us, beckoning, whispering, "Come." May each of you carry that whisper in your heart, and may it guide you to your own stars, your own horizons, your own infinite discoveries. Thank you for walking this path with me, and may every step you take be a step toward the light.